Imagine standing beneath a passenger airplane as it prepares for takeoff. It weighs nearly 400 tons heavier than hundreds of cars combined. Yet just seconds later, it lifts gracefully into the sky. No giant balloons, no hidden rockets, just engines, wings, and the invisible air around us. So how can something so unbelievably heavy defeat gravity? The answer isn't magic. It's one of the greatest engineering achievements humanity has ever created. And once you understand it, you'll never look at an airplane the same way again. Every day, thousands of airplanes carry millions of people across the world. For most of us, flying feels completely normal. We board the aircraft, fasten our seatbelts, and trust that this enormous machine will safely rise into the sky. But have you ever stopped and wondered, how is this even possible? A fully loaded modern airliner can weigh hundreds of tons. Gravity is constantly pulling it downward. So what pushes it upward? Today, we're going to uncover the surprisingly simple science that makes flight possible. No complicated formulas, just fascinating ideas anyone can understand. By the end of this video, you'll know exactly why even a 400-ton airplane can fly. Take a moment to imagine holding a stone in your hand. The instant you let go, it falls. Gravity pulls everything toward Earth. People, cars, buildings, even airplanes. So why doesn't a giant passenger jet simply fall from the sky? That's the mystery. A large commercial airplane can weigh close to 400 tons when fully loaded with passengers, luggage, cargo, and fuel. That's roughly the weight of more than 250 average cars combined. Yet, somehow, this massive machine climbs thousands of meters into the air and stays there for hours. The secret is not that gravity disappears. Gravity is still pulling down every single second. Instead, the airplane creates another force that pushes upward just enough to overcome gravity. That force is called lift. Everything about an airplane is designed to produce as much lift as possible while using as little energy as possible. Its wings, its speed, its shape, even the angle at which it moves through the air. But before we understand lift, we need to understand something even more surprising. Air is invisible, yet it behaves like a real material. Although we cannot see it, air has weight, it has pressure, it flows, it pushes back. And airplanes are designed to work with that invisible ocean surrounding us. Once you understand that, flight begins to make perfect sense. If you look carefully at an airplane, you'll notice something unusual. Its wings are not completely flat. The top surface is gently curved. The bottom surface is much flatter. This special shape has been carefully engineered over many decades. As the airplane moves forward, air splits into two streams. One flows over the top of the wing. The other flows underneath. Because of the wing's shape and angle, the airflow changes around it, creating a pressure difference. The pressure above the wing becomes lower than the pressure below. That difference creates an upward force. This is lift. Another way to think about it is this. The wing also pushes air downward. According to Newton's third law of motion, every action has an equal and opposite reaction. If the wing pushes air downward, the air pushes the wing upward. Both ways of describing lift help explain the same real-world result. The airplane is supported by the surrounding air. This process happens continuously throughout the flight. Every second, every meter, every wing is quietly interacting with the air around it. The faster the airplane moves, the more lift its wings can generate. That's why airplanes need to accelerate before takeoff. Without enough speed, there isn't enough lift. Many people believe the engines are what lift an airplane into the sky. Actually, the engines have a different job. Their main purpose is to move the airplane forward. They create a force called thrust. Modern jet engines work by pulling huge amounts of air into the front. The air is compressed, mixed with fuel, ignited, and then expelled out of the back at extremely high speed. As those hot gases rush backward, the engine is pushed forward. It's exactly the same reason a balloon shoots across a room when released. Air rushing backward, balloon moving forward. Jet engines operate on the same scientific principle, just with far greater precision and power. As thrust increases, the airplane gains speed. As speed increases, the wings generate more lift. Eventually, lift becomes stronger than the airplane's weight. And that's the exact moment the wheels leave the ground. The engines don't lift the airplane directly. They help the wings do their job.
If lift keeps an airplane in the air, why doesn't it continue climbing endlessly? Because flight depends on balance. Pilots carefully manage 4 fundamental forces throughout the flight. Lift pulls upward, weight pulls downward, thrust pushes forward, drag pushes backward. Drag is the resistance created as the airplane moves through the air. It's similar to the feeling of sticking your hand outside a moving car window. The faster you move, the harder the air pushes back. Airplanes are designed with smooth, streamlined shapes to reduce drag as much as possible. Once the airplane reaches cruising altitude, these 4 forces become balanced. Lift equals weight. Thrust equals drag. The airplane is no longer accelerating upward or forward. Instead, it flies smoothly and efficiently across the sky. This balance allows modern aircraft to travel thousands of kilometers while using fuel as efficiently as possible. Every flight is a constant dance between these invisible forces, a dance guided by science, engineering, and skilled pilots.
The next time you watch an airplane lift off the runway, remember what is really happening. The engines aren't carrying hundreds of tons into the sky by themselves. They're giving the airplane enough speed for its carefully designed wings to work with the invisible air around them. The wings create lift. The engines provide thrust. Gravity pulls downward. Drag pushes backward. When these 4 forces are balanced, one of humanity's greatest inventions takes flight. What once seemed impossible becomes a beautiful example of science and engineering working together. And perhaps the most amazing part is this. Every safe takeoff and landing is the result of thousands of brilliant ideas developed over more than a century.
The next time you board a flight, you'll know there's no magic involved, just physics, engineering, and decades of innovation. If you enjoyed discovering the science behind today's mystery, subscribe to Beyond How, where every video uncovers another fascinating question hiding in plain sight. Because the world becomes even more interesting when you understand how it works. Thanks for watching, and we'll see you in the next episode.